This is AS Statistics and we're in Unit 3. We're looking at correlations and bivariate data, and this is 3.2, then going into the product moment correlation coefficient. The product moment correlation coefficient is a measure of the correlation which is given by this formula here. I'm not going to run through every of the pieces, but the two things then are x and y. Those are the two things you're comparing, and this is the formula then to work it out. We do have easier ways of doing this, so hang in there for the minute. Don't be too intimidated by this one as yet, and you'll see from the example hopefully that it's very doable. However, this is usually not a very convenient way to calculate it, as it involves finding the difference of every x value from the mean of the x values and the difference of every y value from the mean of all the y values. A method which is generally more convenient involves breaking the formula down into different constituents as follows. So that top bit there we know as SXY, and that's it there. You can just see that's been copied there from up there. And another way of working out the same thing is the sum of xy minus n, mean of x, mean of y, and that's a much more convenient way of working out then the top line of this formula. So that's what we're going to be using more often than not. For SXX, so this is this wee bit here. You see there's kind of two parts at the bottom that we take the square root of. We get this, we get this. So this here, as obviously that's messy to take every value, take away the mean, and then square it. So this here is just the sum of all the x terms squared, take away the amount of terms there are times the mean of x squared, and that's SXX, and then SYY. So the expressions on the right are often much easier to use, especially as data is often given in summary form. Again, I'll explain more about that in a wee second. Then the formula now becomes R equals SXY all over the square root of SXX SYY. Let's take a wee look then at example 1. A newspaper published an article about children's use of screens. It includes a scatter diagram below which shows the number of hours of screen time per day for a sample of 50 7-year-olds and their reading scores. So there's a scatter diagram. I don't know if you can see there, if you kind of see any pattern at all. It's kind of hard to see. I feel like there's a vague negative correlation going that way, but I'm not sure. It's kind of a lot of wee kind of bits of data down here. If they weren't there, it's really very negative looking, but to me there's no positive correlation going on definitely, but it's kind of hard to say. Alright. The newspaper article states that the data shows that the screen time has a negative effect on children's reading scores, as in the more screen time you have, the bigger the effect on the children's reading scores. The data used for the scatter diagram is summarized as follows. The sum of all the x terms is 222. The sum of all the x terms squared is 1604. The sum of the y terms 2892. The sum of all the y terms squared 179558, and then the sum of all the x times the y is 11846. And this is the summary data here that we're going to use then to substitute it in and work out what we're looking for, where the number of hours spent on the screen is denoted by x and the score in the reading test is denoted by y. Calculate the product correlation coefficient and comment on the newspaper's claim. So we're going to try and find this here. So we need to find three pieces of information. We need to find SXY, SXX, and SYY. We're going to do it using this, and this, and sub it into this formula here, and that's going to give us our number, hopefully. So let's make a start. First of all, we're just going to take things nice and slowly. So we have S, X, X. If you look at the previous page, our formula for that, the sum of all the x squared, take away n mean squared. So that's going to equal the sum of all the x squareds, that's 1604. Take away n is the amount of pieces of data they are, and that's 50. And then we need to try and work out the mean and then square it. So how do you work out the mean of all the x's? You add them all up. That's going to be it there. So it's 2, 2, 2 divided by 50, because there are 50 pieces of information. Again, you need to come up with that bit. So that's the mean, obviously. X with the wee bar on top of it gives x. So it's the mean of the x and then squared. So that's it squared. If you put that into your calculator, you get 618.32. Good thing is, and for SYY, it's very similar. So SYY, that's of course going to be the sum of the y squareds. Take away n times the mean of the y squared. So the sum of all the y squareds is 179,558. Take away 50 upon the mean. So the mean of the y's, how are we going to work that out? 2892 over 50 all squared. Again, put that in your calculator. You get 1224.72. Okay, final thing we need to work out then is the SXY. So our formula for that. Sum of x, y's, take away n x bar y bar. Sum of the x, y's, 1, sorry you can't see it there, 11846. Take away 50 upon 222 over 50, because that was our mean for the x's, upon 2892 over 50. That gives you minus 994.48. We've done all the hard work. We now need to substitute these three pieces of information into this formula here. So R equals S x y all over the square root of S x x S y y. SXY, so that's minus 994.48 all over the square root of 618.32 multiplied by 1224.72. And if you put that into your calculator, the product moment correlation coefficient is minus 0.3608. So this shows then there is a weak, although it's not too bad, minus 0.36 negative correlation between screen time and reading, and that is, I guess, our conclusion. There's an important thing about this. This doesn't mean it's definitely true just because we've got this statistic showing this. And that's the kind of important part, and that's a step up actually from GCSE to A level, is realizing that even though this number suggests it, it doesn't mean it's definitely true. There's plenty of other factors that kind of might be the case. So let's read what it says here. That's kind of what it's saying. In the example above, the value of the correlation coefficient suggests that there may be a connection between the two variables. It does not mean that screen time has a negative effect on a child's reading ability. For example, it might be the case that children who read well spend less time on screens because they enjoy reading books. All that the correlation coefficient shows is that there is a slight connection between the two variables. This illustrates a very important point, that correlation does not imply causation. So even though we found the correlation, it doesn't necessarily mean that watching more screens give you a kind of lower reading age or anything like that.